close. It's not great. Okay, so this is just a brief reminder of how we factor with coefficients other than 1. So this quadratic right here is 4x squared plus 13x plus 3. And we assume it will factor. I can tell you it will because it came right out of the book. So we just got to fight the fight. So what we do is, first of all, we look for anything that's common that we could pull out. 4 and 13 and 3 have nothing in common, and they don't all have an x, so that one's out. So now we write down our 2 sets of parentheses. And this is how I handle it. This one isn't too bad because the 4 is very small and so is the 3. As a matter of fact, the 3 is prime. And so the 3 can only be written. I mean, factors of, okay, let me back up. We're trying to find factors of this to go in the front, because if we were to take these two multiply them back together, the first thing we would do is take this term, whatever we put there, and multiply it by that term, and that would be this one, right? So I need to figure out how I can pull this one apart. And there's 2 different ways. It's either going to be 4 and 1, since 4 times 1 is 4, or it's going to be 2 and 2. And we don't know which one it's going to be yet. The back end of these, when we finish factoring, I mean, if we were to take these 2 factors, whatever they are, multiply them back together, the last thing we would do in the FOIL is the last, which would be to multiply this term, whatever it is, times this term, and it would give me this. So what I got to do to put things here and here is I've got to find factors of 3, and there are only 2 of them because it's prime. There's only 3 and 1. So I know that the back end of this, when I write it down, is going to have a 3 and a 1. It may be the 3 here and the 1 here, or it might be the 1 here and the 3 here, depending on these guys. And it's important, the order, in this case, because that's other than 1. So I'm going to try the 2 and the 2 first. And this is what I would write. 2x, 2x. And then I'm just going to write down the 3 and 1 in whatever order I want. And then this is what you do. And this sign right here is very important. Very, very, it's critical what you do. So what you do is you take this outside, because remember in FOIL, the outside ones you multiply and the inside ones, and they always combine together. Does that make any sense to you? Yeah. Okay. So I need this product, and I'm ignoring the x's when I'm doing this little exercise in my head. I need this product 2, and added to this product 6. So the 2 plus, this is an extremely important sign. 2 plus 6 is 8. So I got the wrong combination because I need it to be 13. Okay, so we erase these, and you can do a lot of erasing, so erase carefully so you don't drill holes in your paper. And we'll put the, where did I have it? Well, if we switch places with 3 and 1, we're going to get that thing back. We're going to get 2 plus 6 again, because the reason why we're going to do that is because it doesn't matter whether the 3 and the 1 are when these are both 2s. Does that make sense to you? I could put the 3 and the 1 different. I would still get a 2 and a 6. Whether the 3 and the 1 was there or like this, I'm still going to get a 6 and a 2 because these are the same. So since this has to be 1 and 3, and it didn't work out, all I got was 8 when I added them together, and I needed 13. I know it's not this 2 and 2. So again, we erase. Leave the 1 and 3 where they are. We erase, and we put maybe a 4, and we'll leave that a 1. In algebra, we know that's a 1. And we try it again. 12 plus 1, 13. Now we consider the signs. We want a positive 13 out of this, so we're going to need a positive 12 and a positive 1. Now, the only control I have over signs is I don't have any control over this 4. That's a positive 4, and I can't change it. Can't mess with it. But I can mess with the sign on this. So it's this that I have to think about. I got to have a positive 12, which means I got to make this positive. I got to have a positive 1, which means I got to make this positive because I have no control over this sign. Right. Follow that? Yep. Okay, let's try another one. I'm going to pull some out of my book, and then we'll try some of yours. Okay? Let's do one with a minus sign in the middle. We got 3x squared minus 7x plus 2. 3x squared minus 7x plus 2. Now this one's, again, not going to be so bad. It's unfortunate that this is not a 1. It always makes it harder when this is not a 1. But the front number and the back number both only have one set of factors that work. 3 and 1 and 1 and 2. So I don't have to make the choice over here like I did, because this had 2 possibilities for the 4. Right. When you start getting stuff like, when you start getting 12 here and 36 here, you're in a world of hurt because you got lots and lots and lots and lots of combinations. I don't think they'll do that to you, but if you do, it's the same process. It just takes longer, as you said. Okay. So I'm going to put the 3x here and the x here. And by the way, that makes absolutely no difference. Now we'll make a difference where we put the 1 and the 2, so we get a negative 7. Now I'm going to show you a little trick here. If I were to put the 1 here, because I'm going to multiply 3 times 1 in my next little bit of it, it's not going to make it big enough. Well, I won't go there. After you have some experience with this, that'll start to occur to you. So I'm just going to put a 2 and a 1. I'm just going to put them down, 2 and 1. And remember, this sign is very important. We're going to add 3 plus 2, and that's 5. That's the wrong order. We want a 7. So we put the 1 and the 2 here, and you can see already, because you know what you're going to do. You're going to get the 7 out of this. It's going to be 6 plus, as that sign, that last sign is real important. What you're going to do with these? 6 plus 1, and that is 7. But I need it to be negative. Now I'm considering the signs. I need that, when we add together, to be -7, which means I'm going to need a -6 and a -1 to get down to -7. Okay. Let's try another one. Like they're making these pretty easy by putting prime numbers first and last. We'll try some without prime numbers as soon as you get this idea down. So I've got 2x squared minus 5x minus 7. 2x squared minus 5x minus 7. Okay, again, I got 2, which means I only have a 2 times 1 out here, and I only have a 7 times 1 over here. These are just little things to keep track of the possible factors, okay? They're both prime. That's the only way to do it. That makes it nice because it makes it really short. There's only one way to split up a 2, and there's only one way to split up a 7. So I'll just split it up and we'll see what we get. Now we're going to subtract to get that 5. We're ignoring that sign until the very end. We're going to subtract this 2 minus 7, which is 5 of swords. You know what I'm saying? 2 minus 7 is -5. We don't care about when we subtract. We really don't care about the sign. We just need to get a 5 when I take this product, this outside product, which is 2, and I subtract. That sign's important. 2 minus 7 does give me a 5.
Right.
Kind of 5. Now I got to think really hard so I can make sure that this is a -5. This was a +2. This was a 7. In order to get down to -5, I need the 7, which is the inner one. I need that to be negative and the 2 to be positive. So to get a -7 and a +2 to give me a -5. That's how you assign the signs. Okay. Does this make any sense?
No, it does.
Yeah? You're good?
Mm-hmm.
Okay. All right, let's try another one that's a little more difficult. That's more like this. That's got more possibilities, and I'll show you how to run those down.
I say mine are pretty off the wall out of my book. I feel.
Okay, all right, give me an off the wall one. The ones they've got for you that are really bizarre and have big numbers, bigger numbers. Go ahead.
I have 18x cubed y plus 3x squared y squared
Okay.
minus 36xy cubed.
Okay. This really takes into account and in great detail and in lots ofness, I guess.
Yeah.
Here, the very first thing you do anytime you try to factor any trinomial, and it didn't show up here because these were extra simple, is you got to find out what they all share in common. It's not what can be divided out. Now they all have. If I'm looking, let me look at the numbers first. I'm going to ignore all the variables. I got an 18 and a 3 and a 36, and I know that 3 will go into all of those. You're good with that?
Yep.
So I'm going to yank out a 3. Now I'm going to consider the x's. I have 3 of them here, 2 of them here, 1 of them here. So they all have at least 1.
Yeah.
Which means I can divide that out of each one. Do you understand what I did? How I did that?
Yeah.
They have at least 1. Each have 1. This one's got a y. This one's got 2. This one's got 3. So they've all got at least 1 y. Now I've got to decide if I divided this and this and this out of each term, what remains? If I divide a 3 out of 18, I get a 6. If I divide an x out of x cubed, I have x squared left. And if I take that y out or divide a y out, I don't have any y's left.
Right.
And the way you check to see if you're right is to multiply this times this and see if you get this.
Right.
Okay. This one, I pulled the 3 out, so it's a 1 now. I pulled out one of the x's and I pulled out one of the y's.
Right.
Okay, so for the 36, it's still negative. I took a 3 out of the 36 and left me with 12. I took an x out, which leaves me with no x's, and I took a y out, which leaves me with only 2 in this term. Got her?
Yep.
Now we have to tackle the remainder using these strategies. Okay, so out here to the side, only because I got that junk in the front right there, I'm going to write down possibilities for this. It's either going to be 1 and 6 or 2 and 3. Right?
Right.
Okay. bugger over here is going to be. And this is where having a pattern, and so that make sure you don't list any twice, but you also don't forget any. I always start out with just the 1 and the 12. And then I go to 2, and if 2 will go into it, I write it down, 2 and 6. 3 goes into it 4 times. 4 goes into it 3 times, which means I've got them all because I've already got that combination. Okay. Okay, so here we go. I'm going to bring the 3xy so I don't forget it later down. I'm going to write 2 sets of parentheses here. And I'm going to tell you, I don't know how your book is written, but the ones we teach in high school almost always go to the more obvious one. So I'm going to try what is, most people say, give me 2 factors of 6. They don't say 6 and 1. They usually say 2 and 3. That's usually more obvious. So I usually try the obvious ones first. So I'm going to try a 2x and a 3x. The most obvious one for 12 that most kids come up with is 3 and 4. This is the next most obvious one, but I'm going to try 3 and 4. And all I'm going to do is I'm just going to write a 3 and a 4 down as your teacher in your book suggests. Just write something down. But this is where my shortcut comes in, so you don't have to write all possibilities. You don't have to write them all. This is where my shortcut comes in. This sign is critical. And so we're trying to get a 1. You see there's a 1 there?
Yep.
Understood 1. We're trying to get a 1. And I have 8 minus 9. I hit it right on. I didn't mean to.
Wow.
Yeah, I was just lucky. I promise it was just lucky. Let me just pretend for a minute that I put the 4 here and the 3 here. That would give me 6 minus 12, which is not 1. And so before I abandon the 3 and the 4, I'm going to leave this combination here. Before I abandon the 3 and 4, I try it in a different order. And that's the reason why they're erasing. There's a lot of erasing. So I put a 3 here and a 4 here and try that, and I get 8 minus 9. Voila, I'm good. Generally, you don't have to try all of these. With your teacher's method, you do.
Yeah.
And
She's
so,
having you write down each.
right. And you got to write down each possibility of signs too.
Yeah.
This method, I don't know who wrote your textbook, and I don't know how often they choose the more natural, but this one happened to work.
Yeah.
What I would do if this didn't work, if I tried the 3 here and a 4 here, and then I tried the 4 here and the 3 here, is I would check this one off and say, okay, I consider both possibilities with these, and I would try this and this before I abandon my 2 and 3.
Right.
Then if none of those work, then you got to put down 1 and 6, all of these again. So it is a lot of trial and error, and these things are a big headache when you have coefficients in front like that. But this is a way to do it which won't waste too much paper and won't make you try every single example. I mean, every single thing. As soon as you hit it, the objective is to hit this product, 8, minus this product that will give you this, either positive or negative, doesn't matter. And if you hit it, which is that minus, I'll tell you, that way you don't have to try all the pluses and minuses, all that kind of crap. Give you 8 minus 9, that gives you a 1. So it tells you everything's in order. Now we consider the signs. We need a positive 1 out of that, which means the 8 is one of the products. 9 is the other. We need the 9 to be positive, and that's the control I have over this sign. This product needs to be positive 9, and then I need to subtract the 8 to get that 1. So this product and this product have to give you a 1. You give the sign, the positive sign, to the bigger one because this is positive. Okay, so it is much like your teachers. I told you in the text, I said it's going to take, it's much like what your teachers do. You don't have to write down every single one. I just keep track of the things that I've tried here. This one just happened to work. Give me another one that may not happen to work, and we'll see if we can, I'll show you how to muscle through it and maybe give you a couple of tips on how to choose. Oh, wait a minute. Sorry. That has a y squared on it, so these have got to have y's on them, so that the last product is negative 12y squared. Did you follow that?
No.
Okay. I forgot to put the y's in here. I was so busy and so concerned about the numbers. This has a squared variable on it. So does this one, which means your n terms here have to have a single variable on it. So when you multiply this times this, you also get a y squared out of it. I did not put that in. I was only worried about the numbers, and I got them. But this one has squared x on the front, squared y on the back. So this has a single x on the front and a single y on the back. And I just forgot those. So got to finish the job. Yeah. Okay.
I go. The next section is perfect square trinomials.
Okay, we can work on those.
But I have a few more examples of the.
Okay, let's do one that's a little tougher. This one just happened to be serendipity. Worked out nicely.
I have 12x fourth plus 17x squared plus 6.
Okay, now this one, things are characterized as being quadratic if their leading term is squared.